Dear students, welcome to today's class. Today I am going to explain a very important characteristic of limit is the continuity of a function, the continuity of a graph. To check the continuity of a graph, what is meant by continuity of a graph? Let us take any graph, for example, x-axis, y-axis. If you draw the any graph without lifting your pen, that means if you are from here you are all drawing like this. So this is called, so y is equal to f of x curve. This is called continuous graph, continuous graph. Then how to check whether the given curve is a continuous or not? For example, you are given one curve. So y is equal to sine of mod x. Then how to check whether the curve is continuous or not at x is equal to some number, some x is equal to 5. For example, this x is equal to 5. How to check here? How to check at that point it is a continuous or it has some breakage? How to check? That is a very important characteristic of the limit function. The limit function. So that is to check the continuity of a function. Very important use of the function limit. What is this? What is that? A function is said to be continuous at x is equal to a. At x is equal to a. That means x is equal to a. Here x is equal to a. If you want to check continuity of the function at some number, some x is equal to a, then we have to check if and only if limit extends to a, f of x is equal to f of a. That means at x is equal to a, that means this is a graph, x is equal to a. From at x is equal to a, the first of all, limit extends to a, f of x should be exist. Limit extends to a, f of x. That means as you are approaching from left hand side and right hand side, your right hand side limit and left hand side limit both should exist and it should be equal to the functional value here f of a. So this should be equal to your functional value, that is f of a. The limit value at x is equal to a should be equal to the functional value f of a. Understand this? So that means to continuous at a point, we have to check the function have both left hand side limit and a right hand side limit at the point a. That means it should have both left hand side limit and right hand side limit it should have, and both should be equal, and that value should be equal to f of a. Then only we will say that the function is continuous at that point. Otherwise it is discontinuous at that point. Understand this? So there are certain functions which are always continuous for all the set of domain of real numbers. Let us see such a type of functions. Very important note point is here. Let us see this. Which functions are continuous? There are certain functions are there. So without hesitation we can say that there are some continuous functions. What are they? All polynomial functions are always continuous. All polynomial functions. What are polynomial functions? Y is equal to 2x plus 3. It is a continuous function. Why? Because it is a straight line. Y is equal to some x square plus 2x plus 3. Yes, it is also a continuous function. Why? Because it is a parabola open upwards. And y is equal to some x cube minus 2x square plus 3x plus 5. All polynomial functions are continuous. There won't be any breakage. All polynomial functions are continuous. Okay, na? That is the first point. Coming to second point, y is equal to a power x, y is equal to e power x, y is equal to log x to the base e. Of course, logarithms are defined only for positive real numbers. Y is equal to mod x, y is equal to mod x graph is this. Y is equal to mod x, it is always continuous for all x belongs to real numbers. Y is equal to e power x, y is equal to e power x, it is always continuous, same as y is equal to a power x, y is equal to log x to the base e, all are continuous. No need to check, they are always continuous function. Okay, now At the same time, sin x, cos x functions are also continuous. I have drawn the graphs of the sin x and cos x function. They are continuous. X belongs to R. They will continuous. X belongs to R. So whatever may be the x value you take, they are always continuous. There won't be any value which you want to get undefined. Sin x, cos x are always defined for all x belongs to real numbers. But for tan x, it is not a continuous. There are breakages are there. Where the breakages will be there? Plus pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. From left side, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2. That is 2n plus 1 pi by 2. So odd multiples of pi by 2, the functions are not continuous. Except those points, the function is continuous. That means at this point, except these points. So if you remove those points, so there if you see, observe the graph, they are continuous. Same time, y is equal to greatest integer function is continuous for all set of real numbers except integers. Why? Because it is, so if you observe here, at integers they are discontinuous. At integers they are discontinuous. Okay. For except the integers, they are all continuous functions. Okay, na? So these are the few things that you have to remember for while solving the problems in continuity of functions. Okay, na? So let us see one more very important formula I am going to tell you to check the to find the left hand side derivative and right hand side derivative of a function. Let us see this one of the very important formula. To find the left hand side limit at a point x is equal to a, if you want to find out the left hand side limit, that is limit extends to a minus means you are approaching a from left side, it is same as limit h tends to 0 f of a minus h. The second formula, right hand side limit, that means if you want to check limit extends to a plus, that means you are approaching a from right hand side, f of x is same as limit h tends to 0 f of a plus h. What is here a minus h, a plus h is it is a neighborhood of a. H is a very small minute value. Okay, right. So using this, how to do, I will show you one problem, that is let us check the function f of x is equal to modulus of x, whether this is a continuous or not. As we know that this is always a continuous function. So this is y axis, this is x axis, y is equal to mod x graph. It is always a continuous graph. We know that by seeing, observing, we can say that. So at x is equal to 0, I want to check the continuity of the graph at x is equal to 0. At x is equal to graph is continuous. At x is equal to 0, why? Because y is equal to mod x is mod x, mod 0 value 0, it is continuous. Everybody we know. But mathematically, theoretically, how to prove that? Let us see that. First, left hand side limit I am going to find out. That is limit x tends to 0 minus. Limit x tends to 0 minus. That means at what, where I am checking x is equal to 0. That is f of x. F of x means mod x. So what is according to the definition? So limit h tends to 0 mod of so this is equal to how much? 0 minus h. 0 minus h. So this implies limit h tends to 0 modulus of 0 minus h. That means modulus of minus h. Modulus of minus h means h, that is equal to 0. Understand this? Right. What is right hand side limit? What is right hand side limit? That is limit x tends to 0 plus modulus of x. Limit x tends to 0 plus f of x is same as limit h tends to 0, limit h tends to 0 modulus of a plus h. That means 0 plus h, modulus of 0 plus h, that is equal to limit h tends to 0. 0 plus h is h, modulus of h is h only, therefore this is equal to 0. That means left hand side value is 0, right hand side value is 0, therefore limit x tends to 0 modulus of x value is equal to how much? 0. Clearly at x is equal to 0, at x is equal to 0, what is modulus of x is equal to how much? 0. Modulus of x is equal to how much? 0. From this, what can you say? Limit x tends to 0, modulus of x is equal to modulus of limit x tends to 0, modulus f of x is equal to f of 0. F of 0 means modulus of f of x is equal to 0. So, this is a procedure, actual procedure to show that the function f of x is equal to mod x is continuous at a point x is equal to 0 or x is equal to 1 or x is equal to 2 anyway. Understand this? So, this is an actual procedure. So, always be remember that to prove that a function is a left hand side limit and right hand side limit. So, these are the formulas that we use for to prove that a function is a continuous or not. Okay. So, based on these concepts, so let us see some problems so that we can understand the concept very clearly and perfectly. Okay. Let us solve some problems. Let us take one problem. So, one function is defined as, if x is less than 1, the function is defined as sin pi by 2 x. If x is greater than or equal to 1, the function is defined as step of x, that is greatest integer function. Check the continuity of the function at x is equal to 1. At x is equal to 1, check the continuity of the function. So, these type of functions are called piecewise functions. Why that? Because some from x less than 1, the function is defined in one way. For x greater than or equal to 1, the function is defined in another way. That means, given a domain, we can make it into any number of pieces. Here only they made only 2 pieces. There are certain problems are there, they make into 3-4 pieces also they can make. So, any pieces they can do. So, that is why these are called piecewise function. Okay now. So, at x is equal to 1, we have to check whether it is a function is a continuous or not. But no need to draw the graph. Don't try to draw the graph. Okay, without drawing the graph only, you have to say whether the function is a continuous or not. So, at x is equal to 1, find the left hand side limit and right hand side limit. So, left hand side limit at x is equal to 1, I am checking. Left hand side limit is what? Limit x tends to 1 minus. It is not minus 1, it is 1 minus. That is a sign that we have to take the function which is defined less than 1. What is the function defined less than 1? So, this is a sign of pi by 2 x. Using h like that also you can prove, but such this type of problems you can do directly. That means x tends to 1. So, in place of x substitute 1. So, this is the sin 90, sin 90 is equal to 1. Now, what is right hand side limit? So, this is limit x tends to 1 plus. That means, we have to take the function which is defined x greater than 1. So, it is x greater than 1 is equal to how much? This is step of x. What is step of x when x approaches to 1? So, see here. So, this is 1. As you are approaching x from right side, so this is equal to 1.5. Step of 1.5 is 1. So, this is how much? 1.0001. What is the step of 1.001? 1. Understand this? This is equal to 1. Otherwise, you can prove the using the definition of h. H definition also you can prove. How? Limit h tends to 0, step of 1 plus h. Understand? In place of x, we will write down 1 plus h. So, this is equal to limit h tends to 0. Limit h tends to 0. We have the greatest integer functions we have. If 1 is an integer, so whatever may be that. So, if it is a k plus h is equal to k plus step of h. Step of k plus h is equal to k plus step of h. Here k should be an integer. K should be an integer. 1, 2, 3, 4, 5, 6 like that should be there. Then only you can take the step function outside. So, here also 1 plus step of h. Then it is 1. Understand this? So, h tends to 0. In place of h, you substitute 0. Step of 0 is 0. Step of 0 is 0. 1 plus 1. So, it is a theoretically, this is a formula. On the formula base also we proved that. So, on the whole, left hand side limit is 1. Right hand side limit is also 1. Both are exist and both are equal, and therefore, limit x tends to 1. F of x is equal to how much? 1. Limit x tends to 1, f of x is equal to 1. Now, at x is equal to 1, at x is equal to 1. So what is the step of 1? That is 1. That means f of 1 is equal to 1. Therefore, limit extends to 1, f of x is equal to f of 1. Therefore, the function is continuous at x is equal to 1. So, there is a very, very nice problem. Okay, I hope that you understand this solution. Let us go for next problem. Welcome to this problem. So, this is a second type of function. This is second type of problems. In the first type of problems, they will give a function. We have to check whether the function is continuous or not at a point x is equal to 1, x is equal to some x is equal to a. This is a second type of problem. What is the second type of problem? They will give that the given function is continuous. It is given that it is a continuous. Then find the value of some k, l, m, a, b, like that they will ask. So, this is a second type of functions in continuity. Okay. So, here it is given that there is a function is defined as, it is also a piecewise function. When x is not equal to pi by 2, the function is defined as k cos x by pi minus 2x. When x is equal to pi by 2, the function is defined as 3, and he is declared that the function is continuous at x is equal to pi by 2. Okay, now then we have to find the value of k. Right, when it is given that the function is continuous at x is equal to pi by 2, therefore x is equal to pi by 2, f of x is equal to f of pi by 2. Limit extends to pi by 2 is equal to f of x is equal to f of pi by 2. Right, it is given that, right, limit extends to pi by 2. What is f of x function is defined? That means x as pi by 2 means what? Pi by 2 plus, pi by 2 minus. That means pi by 2 plus and pi by 2 minus. Pi by 2 left hand side and right hand side same function. What is that function? K times cos x upon pi minus 2x. F of pi by 2 when x is equal to is how much? 3. Okay. So, let us solve this problem. So, if you substitute x is equal to pi by 2, numerator is 0, denominator is also 0, 0 by 0. Let us go for L'Hopital rule. So, therefore, what is the differentiation? Limit extends to pi by 2. Cos x derivative minus sin x, that means minus k sin x by pi minus 2x derivative. How much? Minus 2. This is equal to 3. Okay. X tends to pi by 2. Wherever psi x is there, substitute pi by 2. Sin pi by 2 is equal to how much? 1. Minus cancel. Therefore, k is equal to 6 is your answer. This is the second type of problem. First type of problems are, so the given a function, we have to check whether it is a continuous or not. This is a second type function, second type of problems in which you will be given that it is a continuous, so that you have to find out k value, m value, n value, like that. So, such a type of problem is one more is there. Let us see that model is also very, very important. Here let us welcome to one more problem. Here one function is given, it is also a piecewise function. When x is less than minus 1, the function is defined as 2 sin of minus pi x by 2. When the x value lies between minus 1 to 1, the function is defined as modulus of ax square plus x plus b. When x is greater than 1, sin of pi x, it is defined as sin of function is, and it is continuous at x is equal to r. That is continuous at everywhere it is continuous. That means it is continuous at minus 1, it is continuous at 1, it is continuous at 2, everywhere it is continuous. Then we have to find out the value of a plus b. Okay. So, let us first see here minus 1, 1. So, these are the critical points. There the function turns into another form, right, at x is equal to 1, minus 1 first, and we will take at x is equal to 1. Let us check. So, at x is equal to 1, left hand side limit, right hand side limit. What is the left hand side limit? So, x less than minus 1, that is limit extends to minus 1 minus, that is 2 sin of minus pi x by 2. So, wherever x is there, put minus 1. So, minus 1, if you put minus 1 is minus of minus will become plus, that is sin pi by 2, sin pi by 2 is value is 1. So, that is equal to 2. What is right hand side limit? Limit extends to minus 1 plus. So, what is the right hand side limit? Means x greater than or equal to minus 1. So, this is equal to modulus of ax square plus x plus b. that is equal to how much? Substitute x is equal to minus 1 here. So, this is equal to modulus of a minus 1 plus b. So, we know that it is given that the function is continuous at x everywhere, means it is continuous at x is equal to minus 1. Therefore, left hand side limit is equal to right hand side limit. Modulus of a minus 1 plus b is equal to 2. We got the equation, call it as equation number 1. Now, let us check the continuity of the function at x is equal to 1. It is already given that it is continuous at x is equal to 1. So, that is a limit x tends to 1 plus. 1 plus means what? X greater than 1. X greater than 1 means what? What is the function? Sin of pi x. Sin of pi x means what? Wherever x is there, substitute 1, sin pi. Sin pi value is 0. So, limit x tends to 1 minus. So, x less than 1. So, this is the function that is equal to ax square plus x plus b. That is equal to modulus of a plus 1 plus b. That is equal to modulus of a plus 1 plus b is equal to 0. This implies a plus 1 plus b is equal to 0. A plus b is equal to minus 1. A plus b is equal to minus 1. Already you check it here, you substitute here a plus b is equal to minus 1 here. Minus 1 minus 1 minus 2, modulus of minus 2 is 2. So, that means second equation is also satisfied. Therefore, your a plus b value is equal to how much? Minus 1. Okay, now. So, very easy problem. So, by seeing this problem and format, no need of getting any panic or any afraid. So, easily you can solve this problem. Okay, let us see one more type of problem. Welcome to the problem here. Test the continuity of the function f of x at x is equal to 0 if the function is defined as f of x is equal to like this. The function is defined when x is not equal to 0. That means when x not equal to 0 means on the left hand side and right hand side the function is defined as like this, but at exactly x is equal to 0 the function is equal to 1. So, generally students how they proceed means they will proceed like this. If you start like doing like this, limit x tends to 0, that means you are checking at x is equal to 0. They will take the function as x plus 1 whole to the power of 2 times 1 by mod x plus 1 by x. X tends to 0, okay, you can substitute here 0, 0 plus 1, 1. But what about here? What about here? 1 by 0, 1 by 0. There become infinity, they tends to infinity as x tends to 0, 1 by x and 1 by modulus of the x tends to 0. So, at that time, so can we declare that the limit does not exist? No. So, we have to check the left hand side limit and the right hand side limit using the H formula. Okay. So, let us see that formula. I am finding the limit of this function at left hand side limit I am finding. That means limit x tends to 0 minus. Limit x tends to 0 minus. The function is x plus 1 2 to the power of minus of 1 by mod x plus 1 by x. Now, I am taking x tends to 0 minus. No, I am taking h definition, that is a limit h tends to 0 in place of x. What you have to write down? 0 minus h plus 1 2 to the power of 2 minus 1 by in place of x. What you have to write down? Modulus of 0 minus h plus 1 by 0 minus h. This is the time wherever x is there, you have to write down a minus h. A minus h. Here a means how much? 0. Check the answer for this. So, this is a limit h tends to 0. So, this is equal to 1 minus h. 1 minus h 2 to the power of, see here, 1 by modulus of minus h. Modulus of minus h is equal to h. This is 1 by h minus 1 by h. 1 by h minus 1 by h, totally it will become 0. 2 minus 0, it is 2. Right. H tends to 0. Wherever h is there, substitute 0. So, this is equal to 0. 1 minus 0, 1. This is equal to 1. So, your left hand side limit is equal to 1. Let us check the right hand side limit RHL. Let us see the RHL. So, let us limit x tends to 0 plus. Limit x tends to 0 plus right hand side limit. So, here for right hand side also the same function is defined as when x not equal to 0 means first left hand side of 0, right hand side of 0. the function is defined as same. This is equal to x plus 1 whole to the power of 2 times 1 by mod x plus 1 by x. Let us take the h definition, that is equal to limit h tends to 0. Wherever x is there, you have to write down 0 plus h. 0 plus h plus 1, 2 to the power of 1 by modulus of 0 plus h plus 1 by 0 plus h. So, this is limit h tends to 0. This is 1 plus h, 2 to the power of, 2 to the power of, see here, this is 1 by 0 plus h. 0 plus h means h. 1 by h plus 1 by h, 2 by h. 2 by h. Okay, now. So, here what we are going to do is, don't apply h tends to 0 means here 2 by 0, infinity will come. So, a power m minus n, a power m by a power n. Okay, now. So, let us continue the solution. Friends, let us continue the step. So, this is equal to limit h tends to 0, 1 plus h whole square by 1 plus h whole to the power of 2 by h. 2 by h. So, limit we can apply for numerator and denominator. Limit h tends to 0, 1 plus h whole square upon limit h tends to 0, 1 plus h whole to the power of 2 by h. Okay, now, as h tends to 0, 1 plus 0, 1 plus 0 is equal to how much? 1 square 1 by, this is equal to how much? This is equal to how much? Limit x tends to 0, we have one formula, limit x tends to 0, 1 plus x whole to the power of 1 by x is value is equal to e. Okay, now, that formula we have, fundamental result. So, here also, limit h tends to 0, 1 plus h whole to the power of 1 by h value is e. Already square is there, e square, 1 by e square. See here, left hand side limit is equal to 1, right hand side limit is equal to 1 by e square. LHL is not equal to RHL. LHL is not equal to RHL. Therefore, this function is not continuous at x is equal to 0. We can clear. So, here we make use of the formula h formula. Only using h, limit h tends to 0 formula only, we will use this, we will solve this problem. Okay. So, dear students, I hope that you understand this today's class with some more problems which were given in the previous JEE mains examinations, and tomorrow's class I will come before you. Until then, all the best.